This video serves as part 2 of our OmnIoT SoftHub to Ubidots dashboard series. If you haven't watched the part 1 video or are unfamiliar with either the SoftHub or Ubidots platforms, please see the video description for links to the relevant videos and documentation. In this video, we'll expand on the example presented in part 1, adding a control switch widget to our dashboard. The switch will send a control message to the SoftHub, which will tell the SoftHub to either disable or re-enable the publishing of our sensor data. We'll start by opening our previous ruleengine.xml file and updating the published data action object to listen for incoming messages from our Ubidots dashboard. Per the Ubidots documentation, the topic we'll subscribe to is a concatenation of the device topic we're publishing to, followed by the API label for the device variable we've connected our switch widget to. We save that, and now we'll add the action objects to disable and enable packet publishing. First, we'll add an action object that, when executed, disables processing for our onNewPacket event. Similarly, we'll add an action object to re-enable the same event as well. Now we'll create 2 user-defined event objects. These are the events that SoftHub will queue as a result of receiving specific messages from the dashboard via the topic we've subscribed to. Now for each event, we'll create a single rule. The rule for the disable reporting message will execute the action object to disable the onNewPacket event processing, and the rule for the enable reporting message will execute the action object to enable onNewPacket event processing. And that's all the changes we need to make to the ruleengine.xml file. We'll save the file and then push it to our SoftHub device using the pscp command. Now we'll update the Ubidots demo.mcfg file on our SoftHub device to map our incoming message text to the user-defined events we added to the rule engine file. Again, we're not going into the specifics of how the message mapping works here, as that information is covered in detail in our MQTT introductory video series, as well as the SoftHub documentation linked in the video description. Looking at our switch control widget on our dashboard, you can see that we've changed the values that are sent to be somewhat unique. By doing this, we can be assured that we are reacting to the proper control messages when they arrive. We go to the section of our MQTT extended options configuration file and add the 2 entries we'll need to tell the SoftHub to map the incoming messages to our user-defined events. With that, we've made all the changes we need to make to add our new functionality. So we'll save our file and restart the SoftHub daemon. Looking at our dashboard, we can see that our switch is currently enabled. So once the SoftHub connects, we start seeing our temperature and humidity widgets updating. We'll press our switch, sending our control message to the SoftHub, and per the rules we added to the SoftHub's rule file, the SoftHub stops publishing our sensor packet data and our widgets stop updating. We press the switch again, and the user-defined event to re-enable publishing is queued, and we immediately see our sensor data again being published and our widgets updating. Keep in mind that for brevity's sake, we've kept this example as simple as possible. But it should be apparent that by using the control widgets, you can easily create much more complex logic to be executed on the SoftHub and perform many more actions. In addition to any of the dozens of built-in action objects supported by the SoftHub, You can also queue Linux system commands and/or your own scripts to be run externally. This opens a wide range of additional possibilities for controlling your SoftHub devices remotely via your Ubidots dashboards.